Good morning, everybody. Let me do this. Guess what? I don't need these. This is a rare event. No glasses. Good morning, everybody. And good morning to you, Ruben. This is the first time in about 50 years you'll see me without my glasses on. Oh, by the way, this little mark they put on, I tried scrubbing it off. I'll have to do a little more. They put on the eye they're going to do so they make sure they don't make a mistake, do the wrong eye. But anyways, good morning, everybody. Welcome to a wonderful morning of Chem 1105 with your host, me, Dr. White. And as you can see, I don't know if you can see it, but it's really still dilated. So it's still a little fuzzy. It's getting better than it was this morning. Once it gets normal size, it'll be good. I had my cataract surgery yesterday. My surgeon, Dr. Cabin, outstanding. And by the way, this eye, I don't need glasses anymore. And I can see real far away. Now, the one problem which I was warned about my surgery is before surgery, my up close reading, I didn't have a problem. Now I do. So I'll have to get reading glasses. So if I seem a little farther back, that's so I can see it better. Just so you know, it's still Dr. White, blueberry tea. And I'm ready to get going. Hopefully you are. Good morning. As you can see, I'm excited. It's over. By the way, again, if you need a ophthalmologist, I think I'm pronouncing right, eye surgeon, the one I used in Hoffman Estates, he's located in a building associated with St. Alexis Brothers on Barrington Road in Hoffman Estates, not far from the interstate toll road there. But amazing, fantastic. I definitely recommend him. Again, that's Dr. Cabin. If you know anybody who needs anything to do with their eyes besides an optometrist, email me and I'll send you his contact information. All right, lot to do today. First of all, important information. On Friday, I will be giving test number 4, 1, 2, 3, 4, 4 on Friday. It will cover acids and bases and organic chemistry. And I just realized I didn't open it, so I better do that. All right, thumbs up, people. Do you see test number 4, important information on your screen? Thank you, Elena. All right, just to remember, or remind you, not to remember, but you should remember, on Friday, the 3rd, I will be giving test number 4. It'll be online just like we did before, and you'll get the password. You'll be able to download a password protected PDF file and also other information in case you didn't have it, how to do a PDF file from your test answers on Thursday. I think I have it, will turn on at 9 a.m. On Friday, right around 10 o'clock, usually about 9:55, I will send out a email with the password or the version of test number 4 PDF file you should take. By the way, I got really creative. The two versions are K and W, my initials. Anyways, you'll have until 11:30, unless you're a blue card student who has extra time, to upload and finish and upload your answers to Blackboard by 11:30. And you should take about 40 minutes, but if you take a little more, I won't tell if you won't. Shh. But anyways, test number 4 will cover acid, bases, and organic chemistry. And it has 17 pages, nine problems at 7. Let me get this straight. I guess my eyes aren't working that good. But anyways, let's try it again. It has 17 problems, 9 pages. They're no multiple choice, but some of the questions have multiple part. Usually most students are done. I've given similar face-to-face in about 40 minutes, but you have more time if you need it. And the topic areas, acids and bases, there's 56 points, organic chemistry, 49, and it adds up to 105. So there's five bonus points. Now, on Wednesday, I'll do a review. Today, later, as soon as I get done with important things I should talk about, I'll go through the organic problem set answers. Now, just to remind you, please note that the extra credit project deadline is 12/7/21. I hope you all had a happy Thanksgiving. I did. I got my eyes fixed, or my other right eye fixed. Actually, it was after Thanksgiving. And this is optional, but it's 10, yes, 10 points. And between now and the 7th, do your project before you upload it, email it to me. If there's something wrong, I'll tell you, and that way you shouldn't have no problem getting 10 points. Now, since they don't, all right, where is it hiding? All right, let me remind you also, and thumbs up people, you see Thanksgiving Amnesty Program on your screen? Thank you, everybody. All right, some of you have not been handing in labs, and that's gonna really hurt your final grade, which I don't wanna see. So you have until 12/1 to upload your missing labs to Blackboard. Do it. If you need any help, tonight I will be having a special, because I didn't have it last night, tonight, Tuesday night, same login as Monday and Wednesday, office hour. If you need help with those labs, come to my office hour. I'll help you. So make sure you do that, please. All right, again, this Friday, test number 4. Don't forget, you've got until Wednesday to upload. And tomorrow, Wednesday, I'll also have my office hour. So don't look at my dot here, which tells the surgeon which eye to fix. But anyways, make sure you do it, because it's 10 easy points and part of the amnesty. If you did it late, I won't take off late points. So make sure you hand it in. All right. I think I covered everything I should be covering, other than no, I don't have to cover this anymore. But anyways, any questions so far? Oh, one last thing. I think you have until the 2nd or whenever, but you should have gotten an email from COD. about student evaluations. So if you can, go right ahead and do your student evaluations for me. Now, at this time of the semester, I also tell students that is, if you like what I did this semester, go to ratemyprofessor.com and say something nice to me about me. If you didn't like what I did this semester, I stunk. Hopefully I didn't, but if I did, go to ratemyprofessor.com and put something down. But I think I did. I hope I did a good job. Finally, if you really, really like what I did, send an email with your student email account to the Board of Trustees and copy the president of COD and let them know what a great job I did. If you really, really didn't like what I did, do the same thing. Now, I don't have it now, but later today, you'll see in the left hand of Blackboard, I'll have a new link, important email addresses, which will give you the email address. Oh, that's better. How do you like my haircut? One of the skills from the COVID I've learned is give myself my own haircut and beard trim, which I'm not bad. Don't look. But anyways, I'll have those emails if you want to send them. All right, with that, let's get go. Well, let me ask again, any questions? All right, let's start doing the practice problems for organic chemistry. Thumbs up, people. Do you see practice problems, organic chemistry on your screen? Thank you, Ruben, and everybody else who just let me know. All right, these are important things you should know for test 4 coming up Friday. What is a hydrocarbon molecule? You should know that's a molecule with only carbon and hydrogen atoms. If you want to use the chemical symbol, you can. If you want to write out the names, you can. You should also know what is a saturated hydrocarbon. And that's a molecule with only carbon, hydrogen atoms, and only carbon-carbon single bonds. For this test, yes, there's some more memorization. When I get through with this, I'll run through important information, test 4, that I will be giving you. Now, you should also know what is an unsaturated hydrocarbon molecule. Since the hydrocarbon molecule, it's a molecule with only carbon, hydrogen atoms. And the most important thing, since it's unsaturated, it has at least one carbon-carbon double bond or carbon-carbon triple bond. You can write it out word-wise, or as I did, 2 lines between 2 carbons, double bond. 3 lines between 2 carbons, triple bond. Now, one of the most important things I'll teach you about organic chemistry, how many bonds to carbon? It's so important. It's that important. I have to sneak this in because, and you should know there's four bonds to carbon. Does this look like it's coming right at you? Amazing what I can do with my hands. Organic chemistry. All right. Remember, there's 4 bonds to carbon. And therefore, you should be able to draw in the hydrogens for the following. And if we look at these, let's go to an interesting one. B, you'll see first carbon has 1 line or bond to it. 4 minus 1 is 3. The second one has 2 lines to that carbon, 2 bonds, always 4 bonds to carbon. 4 minus 2 is 2. This carbon, ooh, this is sneaky. 1, 2, 3 lines, 3 bonds to carbon. There should be 4. 4 minus 3 is 1. And this one has 2, this 3, and this 3. Now, let's look at C. Now, the interesting one is this one. How many bonds to this carbon right here? 1, 2, 3, 4. And therefore, 4 minus 4, isn't the math hard in organic chemistry? Yeah. Is 4 minus 4 is 0. And that's why there's no hydrogens on that. And here I have some more, but I think I should share the fun and let you try one. Let's see how my writing is. Oh, it's still good. Draw in the hydrogens for that molecule, 3 points each. Your turn. And good news, things are starting to clear up even more on my right eye. That is good news. And once again, I'll say, thank you, Dr. Caban. And plus the nurses and the staff at the Hoffman Estate Surgical Center were fantastic. I even asked to talk to the head nurse yesterday to ask her to thank everybody on my behalf for the outstanding job they had. One of the things as a senior research and development manager, as a senior manager in international chemical companies, you always hear bad things, but rarely good things. And when someone does something really good for me, I like to thank them. It doesn't cost anything, but it means a lot to me and to them. All right, let's do this. How many bonds to carbon? This one, I see 1. Remember, there's always 4 bonds to carbon. 4 minus 1, 3. So now this carbon has 1, 2 lines. 4 minus, there's always 4 bonds to carbon. 4 minus 2 equals 2. So I'm going to put 2 hydrogens there. Whoa, my writing is even looking good. I am happy camper. All right, let's look at this carbon. There's 1 bond to it. 4 minus 1 is 3. Ooh, let's look at this one right here. How many bonds? I'm going to go more technicolor on you. 1, 2, 3, 4. And 4 minus 4 equals 0. So I don't have to write any hydrogens there. Now let's look at this one, 2 bonds to carbon. 4 minus 2, because there's always 4 bonds to carbon. Let's look at this carbon right here. There's 1 bond to carbon. That's this line right here. And 4 minus 1 is 3. And now we have this carbon right here. How many bonds? 1, 2. 4 minus 2 is 2. And the last one right here. 1 bond to carbon right there. 4 minus 1. Because remember, there's always 4. Yes, 4 bonds to carbon. And there you go. Now, the next one is how many carbon atoms, not hydrogens, just carbon atoms, are in the following molecule? Well, if we look at A, just count the C's. Carbons, 1, 2, 3, 4, 5, 6. Now in B, we have a ring. That's what this is called. And every bend in a line is also a carbon. So how many bends 1, 2, 3, 4, 5, 6. And then outside the ring, I have 4 on top and 2 underneath. 6 plus 4 plus 2 is 12. Now, if we look at C, Dr. White got sneaky. There's an oxygen there. You don't count that. We're just counting carbons. So I have, oh, a ring again. How many bends? 1, 2, 3, 4, 5. 5 in the ring, outside the ring, 2 here, and 3 here. And therefore, that's 5 plus 2 plus 3 is 10. Now it's your turn. How many carbons? And notice I drew it correctly because each carbon has 4 bonds to it. How many carbons in that molecule? Your turn. Everybody should be done by now. And it looks like you are, so let's do it. How many carbons? Count the C's. 1, 2, 3. So there are 3 carbons. Now, why did I write this molecule? This has 2 names. The official name is 2-propanol. Official meaning IUPAC. That's an international organization that was set up by a treaty back in 18 or 1919, to have rules to name all chemicals. And most of their rules are for organic molecules. Now, you know it as another name, a common name. Isopropyl alcohol, this molecule. Now you take 70% isopropyl alcohol and 30% water, and that's something you know as rubbing alcohol. Might be, that looks terrible. Let's try it again. And that's the stuff, I guess, you rub on your skin. And if you're old enough to remember, like Dr. White is, before digital thermometers like they have now in the doctor's office, you had the glass mercury ones. And to make sure you didn't catch whatever the last patient who used that did, they store these in a little container with rubbing alcohol because it's a very good disinfectant. And one of the first things I did when the pandemic hit hard, before other people realized what to do, I went out and bought a couple of bottles of rubbing alcohol. And about 5 years ago, maybe a little longer, they also started making 90% and 10%. And that's what I got first when the pandemic. And now I'm making sure I have good supplies with the new Omicron just to be safe. All right, let's do another one. How many carbons are in this molecule? 3 points each. Your turn. All right, I think everybody's done. Let's do it. How many carbons? Well, this is a ring, and each bend in a line is a carbon. 1, 2, 3, 4, 5. So the ring has 5 carbons. This is 1, 2, 3, 3 carbons. This is 1 carbon. So if I add it up, and correct me if I'm wrong, there are 9 carbons in that molecule. And that's the skill you should know for Friday. Hint, hint, wink, wink, my left eye. Say no more. Oh, by the way, my right eye winks too. Next, circle the functional groups in the following. How do you know what is a functional group? That's a collection of atoms in a organic molecule. Anything that's not carbon or hydrogen atoms or not a carbon-carbon single bond is a functional group. Carbons alone are not. And this is a way organic chemists have developed a system to understand how to make important transformations and understand also molecules, organic molecules. And if we look at A, an oxygen with carbons here, it's called an ether, but you don't have to know the names. And here, carbon double bond to oxygen with hydrogen. This is called an aldehyde. This one has 1 carbon. Oxygen is the giveaway with hydroxide hydrogen on it. This is called an alcohol. And here I have quaternary ammonium salt, nitrogen, oxygen, nitrogen. This is called an amide. So how do you determine if you have a functional group? Look for anything that's not carbon or hydrogen or not a carbon-carbon single bond. And those are called functional groups. Two or 3 points, circle the functional groups in the following. It's a 3 for whatever, Tuesday. And there you go. A, B, and C, do them all. I can go take a walk around the block. No, I'm not. Circle the functional groups, 2 or 3 points each. I should be humming game show music. No, I don't want to ruin your day by going dun dun dun. I see I ruined it. It's awful third Tuesday humor. And a quick commercial from Dr. White. Don't forget, tomorrow I will be doing my world famous review for the next test, and that's test number 4. I was trying to look at my watch, and I got to hold it back because my short vision is gone. Up close reading vision, which I'll have to get some readers, which is an exchange I'll make any day of the year, because if I hadn't got my cataracts taken care of, eventually I would have been blind. No, thank you. All right, let's do this. Circle and name the functional, well, you don't have to name it. That's when I teach organic. Circle the functional group, 2 or 3 points each. All right, what do we look for? Something that's not carbon or hydrogen. Ooh, nitrogen. And this is called an amine. Ooh, oxygen and oxygen with hydrogen to the same carbon. This is called a carboxylic acid. By the way, what I just drew here is one of the amino acids. Now, what do we have in B? Ooh, a nitrogen. And that's called an amine. We're not done. Oxygen with a hydrogen and a carbon, you circle that, that's a alcohol. Now, ooh, carbons, no, look at this. Oxygen, double bonded to a carbon, this one, that's called a ketone. Ooh, my hydrogen looks awful, that's better. Carbon with the oxygen, that's what gave it away. Look for what's different, what's not carbon, C, what's not hydrogen, H, should get your attention like that, or better yet, like this. Anyways, OH, hydroxyl group on a carbon, alcohol. Ooh, another oxygen, double bond to carbon with a hydrogen and a carbon here. You don't have to know that, but that's an aldehyde. Now, give the reaction product for the following. How do you do that? You have to learn that any saturated hydrocarbon, or actually any hydrocarbon reacting with oxygen, you need a little heat source like a spark, is combustion. Propane, this is a saturated hydrocarbon, oxygen, always gives CO2 and water. For this, I'm not asking you to balance it, just give the products and CO2 and water. And if we have another saturated hydrocarbon, same thing. And a third one, oh, I forgot to put C down. I better do that. Oops. And the question is, what are the product or products are the following? What is this? Is this got carbon-carbon single bonds and a hydrogen? So that's a saturated hydrocarbon. Plus O2 gives me CO2 plus water. This you have to memorize. How do you memorize that? Write it down and say it 5 times. Works better than flashcards. Trust me, I'm an organic chemist. Did that work? And you'll get here CO2 plus water, which is the answer I forgot to put. And if you ever drive around in the dead of winter and you see the car in front of you and you see a liquid coming out of the tailpipe of the car and say, oh no, it's leaking gasoline. No, the muffler and the tailpipe are still cold, and the combustion from gasoline, which is a lot of saturated hydrocarbon, the water is condensing, and that's the liquid coming out. When it's hot, it's a gas which you don't see. Now, next one, give the reaction product or products are the following. And how do you do that? You look for what's different. What's not a carbon-carbon single bond? Ooh, a double bond. And you have to learn double bonds reacting with hydrogen and catalyst. Catalyst can be nickel, platinum, or palladium. You break one of the bonds, each carbon of that double bond, in this case, gets a hydrogen. You don't break carbon-carbon single bonds, never. Well, not almost never, but most of the time, especially in this class, other than combustion, which we just did. So there are 4 carbons, 2 carbons, double bond. There's now only one line, and hydrogen, hydrogen each. Same thing for E, same reaction. This you have to memorize. Well, if you don't have to, but if you don't want to do good on test number 4, then you should. And everything else comes along for the ride. And that's the beauty of functional group chemistry and organic chemistry, is that when you do certain reactions, only the functional group that reacts with that reagent will, or chemicals, will change. Everything else stays the same. Here I have 1, 2, 3, 4, 5 carbons across, and this carbon, which is called the methyl group, here, they're still attached. I break one of the bonds, and each of those 2 carbons gets a hydrogen. Same thing here. And it's your turn. Now I'm going to be real kind today and show you the general reaction. And right here, your turn to put in the product or products for that reaction. And don't forget tonight, special office hour 5 to 6:15. If you need help with the labs or anything else, please stop by. All right, let's do this. How do you do this problem right here? You look for what's different. Oh, a double bond. reacting with hydrogen and nickel, you need to memorize double bond. You break one of the bonds, it's called a pi bond, and each carbon of that double bond gets a hydrogen. Do you break carbon-carbon single bonds? No. So I have 3 across and this one. Here are my 2. I'm going to break one of the lines. There's 2 bonds. Now there's only 1 bond between those 2 carbons. And now I know there are 4 bonds to carbon, so I'll fill in the rest of the hydrogens. Now, if you didn't want to, you could just do it this way. And each one of those got a hydrogen, just like here. You can put it on top or bottom, it doesn't make a difference. Or you could have also written it, which you don't have to. Like that. And you should know how to do that. Next, a few things you should know. I don't know if I mentioned it, but I'll mention it now. What's tallow? It's an important chemical used in the United States. That's beef fat. If you cook a hamburger, the stuff left in the frying pan is fat mainly, and that's processed in the United States, actually comes from butchers and slaughterhouses to make tallow, beef fat. And pig's grease, or you know it as lard, there are 2 different types, yellow and white grease. Now, leaving my class this semester, I expect all of you to know how does soap work. And notice I say hint, give the structure of soap, and talk about micelles. Soap, all soaps, liquid or bar, non-polar tail, polar head. Use water, that's polar. Dirt, non-polar, so is grease. And the most important thing, how does soap work, is light dissolves light. Things that are polar are soluble in polar things. Things that are non-polar are soluble in non-polar things. And if you mix 2 together, they're not soluble. Well, if we magnify that little piece of dirt, I'm trying to get off my hand, and use soap and water, the dirt is non-polar. The tail of soap is non-polar. Light dissolves light. The tail wants to be near the dirt, and the polar head wants to be on the outside, far away from the dirt. And this is totally surrounded. I only show 2, 4, 6 of them, but there's lots and lots, almost Avogadro's number, maybe not that many, but lots. And this is what a micelle is, and you should know that. And now water looks at the micelle and sees the polar heads and says, oh, micelle, you're polar, I'm polar, let's go down the drain together. And they do. Now, how does a towel work? You should know this. Remember, towel is made up of carbohydrates, which have hydroxyl groups, OH, and they can bond, hydrogen bond, not chemically like a covalent bond, but still it's an important force to water. And that's how you get your hands or whatever you're trying to dry with a towel dry. And those are all things you should know. Remember, there's 4 bonds to carbon. 4. Also, do you break carbon-carbon single bonds? No, that will help you for test number 4. Now, I say I got 4 minutes before we're going to take a break, and we're going to do a lab today and something else. And I'm trying to think. I don't think I did. How do you clean a bathtub or shower stall in a couple of minutes without heavy scrubbing? Well, you can go out and buy those chemicals like CSL or whatever it's called. But since I haven't seen the ingredients label, I'm not going to touch that stuff. But a number of years ago, I was cleaning my bathtub. It had all that soap scum on it. That's the worst job I ever in my house. I hate. I let it go too long, which makes it even hate it more. Well, I finally one day said to myself, I'm scrubbing away. You're an organic chemist, you know better. How do you get rid of that? Well, soap scum is a disalt of the soap. It's called the carboxylate anion. And the minerals, calcium in your water, especially in Chicagoland, makes a new molecule, which is very large and precipitates out of the water and forms all that gunk on your bathtub and the walls too. Well, acid will get rid of that. Well, vinegar, which has acetic acid, is very weak. And I looked around and found a product which my brother-in-law had been told me about for another reason. And let's make sure I'm sharing. Everybody see the pictures of Barkeeper's Friend on your screen right now? And you can get this at anywhere, Jewel, where else? Walmart, Target. Everybody see that on your screen? Thumbs up, people. Okay, thank you, Ruben. And this contains soap plus an acid, which is oxalic acid. And what happens is that acid will break down. If I was in organic chemistry right now class, I'd show you the chemical reaction, but breaks down that scum to something smaller that goes down the drain easy. So what do? You take, and I have one of those removable shower heads, my bathtub, shower stall in my main bathroom, and same thing in my other one, which is the shower stall, and you wet it down the wall in the bathtubs with hot water. Then you take that and you sprinkle it like this on the walls of the bathtub, take a paper towel because the sponge gets moistened a little, and make a paste and rub it. Then wait about 15 minutes and then come back with a paper towel. If it's really, really nasty, thick, those green 3Ms or other people make them now too. Scrub scouring pads, don't use steel wool now. And just a little like this takes about 5 minutes to a whole bathtub and wall, and rinse it down with warm water. And actual time to clean up and the actual physical time is under 10 minutes, a lot under. And you got to wait 15 minutes and it cleans the bathtub like that. And speaking about like that, it's time for Dr. White to take a 5-minute break, get up and stretch. I'll be back in 5 minutes and we'll do the lab. But before that, there's 2 things that I want to teach you that won't be on the lab. Okay. And I'll see you in 5 minutes. Time to start again. All right, what I'd like to talk about is something that won't be on the test, but something you should know about. And let me open up something. All right, thumbs up, people. Let me check and make sure you should see it. Everybody say Hurricane Katrina from Wikipedia. Thank you, everybody. And back, what year was it? In 2005, some of you probably don't remember this, but I do. There was a major hurricane in the Mississippi, Louisiana area and killed a lot of people. It destroyed a lot of everything. And because of that, and especially in New Orleans, it was a very bad time. And that's to put it mildly. Because of all the homes, apartment buildings, and trailers, people living in trailer parks that were just totally destroyed, FEMA contacted trailer companies in the United States, mainly in Indiana, they're located, to make a couple 100,000 trailers. Well, it turned out, this is my conjecture, but I believe it's true, there was a shortage of wood in the United States, plywood, because of the hurricane, and they got a lot of wood in from China. This hasn't been made public. But anyways, after a while, people were getting sick who were living in those trailers. And a very brave woman, Becky Gillette, who was part of Sierra Club, with her own money, you can see Wikipedia has an entry for FEMA trailers. And if we go to health problems, we'll see started about a year later, less than a year, people got very sick, especially young children and older people, and animals, their pets got very sick. And they don't have this here. And I'm going to have to go back. I didn't realize it and change something here. But anyways, this very brave woman, Becky Gillette, used an outside laboratory to prove, and I never asked Becky how, I'll explain why. I'm going to have to do that next month, send her an email. I haven't talked to her in a couple of years. That formaldehyde, an organic molecule, was causing this. Now, what is formaldehyde? It's a molecule that's reacting with other molecules, phenol, to make an adhesive or resin, that's a fancy way of saying glue, that holds sheets of wood together or pieces of wood together to make plywood and particle board. And if you make that resin wrong, you'll have a lot of unreacted formaldehyde in there. And it's cheaper to do it that way, but it's more hazardous. In the United States, because of worker regulations from OSHA, that level is kept very low. How do I know that? Because I worked for the company that was the major supplier of that glue resin in the United States, if not the world, but mainly the United States. I worked in another area where they use that same, similar, but not the same resin for making a glue to hold on, let me see if I have one handy. Sand together, this is sand, and it's black because of the resin, once it cures, turns black. And this is called a dog bone to test how good the resin is. They put it in a machine, see how much force it takes to pull it apart. But we also made molecules for the plywood industry. We call that forest products. Well, when I heard about that and the fact that this brave woman was fighting then FEMA and President George Bush, the second one, over to formaldehyde. I was able to track down, I heard about her in the news. I tracked down her phone number, called her and said, talked to Becky and said, I'm an expert in formaldehyde and how to use it. If you need my help, I will not charge you one penny. And I did help her and others too. And one of the things she asked me to do after Bush ended his second term, presidents only think I'd have 2 terms, and Obama was elected, Becky asked me, one, to write a letter because of my credentials to the director, that's not the right, the administrator of EPA, who's in charge of the EPA, and also to President Obama. Yes, I did get a form letter back from him. It's been scanned and I keep it as a memento. It was probably computer signed, but to ask for certain regulations on plywood and other wood products so people don't get sick like that. Because of me and other people who have done that, did that, we now have regulations to protect you from that. But still, sometimes you got to watch out. So another thing Becky asked me to do, and if you looked at the previous Wikipedia, Henry Waxman, who was a representative, had a special select committee of Congress to investigate that. And they were going to have a live congressional meeting, or I forgot the right name for it, where they'd have the owners of those trailer companies come in and testify before that committee. And it was going to be on TV. Well, before that, Becky called me up and said, could you please call this person? He's the lead investigator for Henry Waxman's, Representative Waxman's Select Committee of Congress. They're going to do this committee meeting with those owners, and he wants to talk to you, learn about formaldehyde. Can you help him? So I did. I can't remember his name. And we talked for about 45 minutes or an hour. And finally, at the end of that, I said, could you do one big favor for me? He said, what? I said, could you ask Congressman Waxman to ask the owners of the companies that made those trailers that were getting people sick, where did they get their wood from? And immediately said, I can't. And immediately I knew I wasted 45 minutes or an hour of my life, because they knew what the problem was. And this, having this investigation meeting on TV was just a way of showing, oh, we're being investigated and trying to do our job, otherwise known as PYA, protect your you know what. But they really didn't want to do anything to change things. And I was pretty disgusted too when I realized that, but I was polite to that person. But what that means is, even today, if you buy a product, especially if it's made in China, that is not solid wood, any kind of furniture, which has plywood or other particle board made with that glue, it might be bad and giving off formaldehyde. How do you know? Let me show you. This will not be on a test, but it's something I've been teaching students ever since I and this is, there's a picture of Becky too. And this is her site. I don't know how often she up, now it's been pretty much, but if you notice here in the middle, everybody see in the right hand where it says test for formaldehyde, kits to test trailers can be purchased by this company, 39. Do you see that? Give me a thumbs up if you do. Thank you, Gabrielle. And this is the company Becky used originally to prove there was formaldehyde. President Bush and the head of FEMA, Brown, I can't remember his first name, who was a total idiot, tried to prove Becky wrong. And the EPA scientists who tested the same thing as Becky did proved that this company did a great job. Now, what does that mean? And here's important because I learned by talking to people Becky put me in contact with who go out and test homes for formaldehyde, that it can be pretty nasty. If you know anybody who got new kitchen cabinets that weren't solid wood, which nobody gets those unless you're a millionaire, have that kitchen tested with that product. If you know anybody who has a newborn and they went out and bought new furniture and a crib, have that baby's room tested. For $39, they send you this like a circular badge. You take the cover off, leave it in a room for 24 hours, put it back in a packaging they give you that's already prepaid, put it in the mail, and within about a week and a half, 2 weeks, you can either have it by US mail or email sent to you the results. And they'll tell you whether you got a problem or not. And I would highly recommend that because Becky's friend, who I talked to, who goes out and tested, told me about a story. One of her clients was a couple. He was a hockey player back then for a National Hockey League, meaning he made a lot of money. And she was a stewardess for an airlines, made a lot of money too, I guess. And they just spent $50,000. They have their kitchen remodeled, new cabinets and everything. And turns out afterward, whenever they were home, they got sick. And these were two very healthy people. When they were on the road, he playing hockey or she on the, taking flights, doing her job, weren't sick. And it turned out it was the formaldehyde coming from the cabinets and the wood came from China, I'm sure. So I just wanted to teach you that. If you ever have a question about that, always feel free to email me. I'll always help. That's just part of the way my parents raised me to be a socially responsible person, in this case, socially responsible organic chemist. All right, I got it in again. It's lab time. Today's lab deals with an interesting compound that you're probably familiar with, but you don't think of it as a chemical compound, but it is, and that's starches. And starches are the good things in life that Dr. White shouldn't eat too much of, like potato chips, French fries, rice and potato, all those good things in life. Amazing. And what's a starch? Well, let's look at the lab. And we're talking about carbohydrates, but really it should be starches lab. Now, it turns out that long ago, I better share this with you. Long ago, scientists found that if you take iodine, which is a red, brown, or even a brown color material, and you put it in with a starch, the color changes to a very dark blue. And sometimes it's so dark it looks black, but it's really, if you look hard enough, you'll see it's a very, very dark blue. Well, there's a problem. This is a solid. So someone found out that if you take iodine and react it with either potassium or sodium iodide, you get this. And this is potassium iodide, and this is really this. And this is an ionic compound. Which is polar. Iodine is nonpolar. And you have learned, like, dissolves like. I can spell, it must be I can't spell Tuesday. I can blame it on my eyes. Not really. And what that means is it's always nice to have a liquid you could put a few drops on. So this is water soluble. So if you have something, a food, and you add a few drops of Ki3 solution, if this food contains starch, this is a reddish brown. But with the starch, the color is dark blue. Or it actually looks black. But if you really look hard and under bright light, you can see it's very, very dark blue. Well, before we had the modern electronic instrumentation that organic chemists now use, back about late 1800s, 1900, early 1900s, when they were starting organic chemists to investigate food, one of the important things was, is there starch in this? Well, let's test. And the test was, you have your food, put a few drops of this Ki3 solution, and if it stays red-brown, no starch. And if it turns very, very dark blue, almost black, there's starch present, and that was important to know. And that's what you'll be doing in today's lab. Now, what you'll do, and if we were in a lab on a small glass dish called a recrystallization dish, you'll put a few drops and a mixture of alcohol, iodine, Ki, and potassium iodide is called tincture of iodine. That also has antimicrobacterial properties. And when I was a little boy, before we had the products that we now use for a cut, you got a cup or scrape, your mother would put a few drops of tincture of iodine on that. And because there was alcohol in there, it burned like heck. Ugh. But it keeps you from getting infected. Now they have products that don't need alcohol. Now let's go out to YouTube.
Writing's not that easy, but Grammarly can help.
Wait for the commercial to be over.
Our daily food are carbohydrates, which we consume in the form of starch. Starch is a high-calorie food that converts to sugar during digestion.
Thumbs up, people. Can you see the video?
Produced by all green plants as an energy store.
Thank you.
Today, we will conduct an experiment to test the presence of starch in potato, rice, sugar, and salt. For this, we will need iodine solution, which is yellow-brown in color. Note the change in the color of iodine as it is put on the rice and potato. Both turn the iodine blue-black. Put some iodine on the sugar cubes. The color does not change. Salt too does not change its color. This proves that sugar and salt do not contain starch, while the starch in rice and potato reacts with iodine to form a blue-black compound. Now, the reaction is because the blue-black color is basically the formation of polyiodide chains from the reaction of starch and iodine.
Now, little story before we continue with the lab. Back when I was, I teach in another school, Elgin Community College, and we do this lab also in organic that I teach over there. And I used to teach organic at COD too. At COD, the school would buy the cheese. For whatever reason, I'm not going to go into, at ECC, I'd have to go out and buy the cheese, which is one of the things I had to test for. So one time when I had to go out and I went to my local supermarket, Valley Produce, they had on sale, the individual wrapped cheese, the yellow stuff. And I figured I'll buy some. And students put that cheese shouldn't have any starch in it. And they put some of that tincture of iodine and changed color. What the heck? And I went over and did it changed. Then I looked at the label of this cheap on sale cheese. And I realized why it was cheap, because it contains starch fillers. That way they put less cheese in there. So I bought some next time we taught the lab. I bought some more expensive white cheese that I read the label, not named after me. Bad Humor Tuesday, sorry. But anyways, and it didn't have any starch in it. So if we look at the lab, what you would be doing is testing these foods by adding a couple of drops like you saw in the video, and potato and bread, like potato bread. And notice the yellow cheese changed, but brown for this one instead of reddish brown means it didn't. And notice I also have other dangerous chemicals in the lab: flour, cereal, sugar, honey, and cornstarch. And you would have seen that just like in the video. You would have done that. And now for the rest of the lab, you've got to answer these questions. And with that, that's today's lab. I look at the clock. You had a nice morning of chemistry with your host, Dr. White. Don't look at the mark that still hasn't worn off. I'm not going to, anyways, my dot moved over from this side to this side. But anyways, that made sure they did the right. Don't forget tonight, special Tuesday, only this week, office hour. If you haven't handed in labs, please hand in the labs. And if you need help with anything for test number 4 coming up this Friday, stop by. I will help you. And tomorrow, I'll do my world famous review for the next test. And I didn't do it now, I'll do it tomorrow. I'll show you important information, test number 4. With that, I'm done. Gang gesund. Goodbye. This is gang gesund. It's healthy. I'm happy. I'll see you tomorrow. Gang gesund. Bye now.